Hello, everyone. Can you hear me? Great. All right. So I'd like to speak with you about improving foundation models via human data. So first, let me give you a lay of the land in terms of what are the commonly available levers for improving foundation models, right? There is a portion of well-understood levers that that a lot of research goes on and that many people work on. I mean, we all hear repeatedly that more GPUs are important. There are GPU marketplaces. There are companies. There is algorithms to optimize GPU allocation. There's all sorts of things. Obviously, there's a lot of research that goes into algorithms as well. And of course, there's a certain amount of common crawl pre-training data across the internet that is available to everybody. But because these are so well understood, they often do not end up generating much of a competitive advantage for companies. A lot of the key competitive advantage, what makes some of the models the very best in the business, etc., largely comes on account of access to proprietary human data. And so this is a sort of less understood lever, but probably as a result of that, one of the most powerful ones as well. And what is also very interesting about this, which I'll get to during the course of the talk, is that human data in a lot of expert domains, examples as little as, say, a few thousand data points can already start to show you very early improvements, which is what even makes many of these things economically viable. And this is the unfair advantage that Turing brings to the table, and this is why I'm shedding more light on this topic. Now, I'll tell you a thing or two about Turing before getting into the best practices. So, Turing today helps the world's foundation model companies improve model performance for reasoning, coding, agents, and various other capabilities. And our unfair advantage comes because we have one of the largest talent pools in the world. Our talent platform has more than 3 million software developers and knowledge workers from over 100 countries. We vet them very thoroughly for a range of technical and non-technical skills. And as a result, we have a very detailed profile of them and what their specific competencies are. We work with the who's who. You can see all the big names on this slide in terms of human data for expert areas. And we help with human data for a whole bunch of areas, including evals, SFT, and RLHF. I already mentioned the first point that the sheer size of the talent pool and the fact that the talent pool is vetted is key to our competitive advantage. One understated competitive advantage also that comes because of the diversity of our talent pool is that ultimately there is just a lot more diverse trained data. It's a lot better than a company setting up an office in some particular city in the world, training knowledge workers locally and so on. And apart from, of course, the fact that by casting such a wide net, we get access to a lot of expert talent, and it's possible to staff a team of all A+ talent, which can be very difficult to do if you had to build large teams very swiftly in a single location. And as a result of, again, this large talent pool, there is very specific things we are able to do when it comes to helping with human data on the LLM training side. Specifically, in a lot of expert areas involving rare skills, we are able to spin up teams involving hundreds of knowledge workers in a matter of mere weeks, ensure that the team is fully productive and generating high-quality data. That is improving the models rapidly as well. Okay. Now, let me now get to now that you know where I'm coming from and where a lot of my insights and intuitions come from, let me share with you a whole bunch of best practices with regard to the human data lever itself for improvements. So, typically, the way the best practices with regard to using human data is something like the following. Human data, first of all, today has been primarily used at the post-training step. There are some conjectures and regarding whether these ought to be included in the pre-training step, but that is still like early stages. For most part, the best practice is still using it in post-training. So the common process is, first and foremost, one has a mechanism for identifying a backlog of areas for model improvement. Part of this can come based on the goals of the specific company. Some companies, of course, are looking to pursue AGI. They are looking to improve the models across the board. There are various other companies in specific domains and industries, some of our clients like ServiceNow, Salesforce, many others who are interested in improving models in specific areas also. And this can come partly from company goals, partly from our identification of the company's model weaknesses, from their gaps against the state-of-the-art models. It can come from all of that, essentially. And what we then do is we engage in continuous optimization in different areas across a whole range of areas that are of interest to the company. And to the extent possible, we try and reallocate talent to a very similar task that pulls on the exact same skill set. And now, within a specific area, this is what the loop, roughly speaking, looks like. The most important thing of all is one has to assemble a team that is very skilled in the specific domain of interest, doing that cost effectively, and so on, since practical experience that anyone will tell you in this domain is that if you have B or C grade talent when it comes to skill in a particular domain, even if you have the best quality control process, you're not going to get very far. That does become a necessary condition, if not a sufficient one. Then a common practice is to generate an evaluation data set for the specific domain. Now, the reason for generating evaluation data sets for all of these is, first of all, there is often not very good public benchmarks for many narrow areas of interest to companies. Second, a lot of public benchmarks are tainted by both hard and soft leakage issues. Like there are very similar questions on the internet that the models has already been trained on and everything. And therefore, it's always good to put an eval set together from scratch. Then a common practice when the model is at very low levels of performance in a specific area is to engage in supervised fine-tuning data sets. And I'll get into some more details regarding what those look like. It is these kinds of tasks end up being relatively more complex. For a wide range of tasks, it can take anywhere between, say, half an hour to 2 hours to put together one high-quality data set end-to-end, including all the time for reviews and rework. Then there's reinforcement learning from human feedback data as well, where one is interacting directly with the model and giving it feedback. And again, as I mentioned in a previous slide, the fact that one often gets to a very good place in something like a few tens of thousands of data points is what makes many of these strategies very economically viable. Now, obviously, once you have a certain human data team, the goals are suppose you've identified valuable areas and you've defined the tasks sensibly and everything, what one seeks to optimize is quality and throughput. First and foremost, the quality has to be of the highest level, because in all things machine learning, and LLMs are no exception, poor quality data just means it's not going to learn very much. High quality data is paramount, especially in expert areas where it's difficult to do so. And of course, conditioned on getting good quality data going, you want to maximize throughput to get the highest ROI that you can. And often a bunch of human processes to do with the reviews and rework and various kinds of processes that can vary based on the kinds of tasks can be important here. These are, for example, the kinds of steps we have found quite useful. Like, as I mentioned, there is step one, which is ensuring that the trainers themselves are high quality and highly skilled in a specific area. And number two is, of course, ensuring that you actually have good processes and good tooling and everything to make sure that you're able to realize the potential of that particular team and you're getting the most out of that team. So here are a bunch of sample areas that can be improved via human data. This is, of course, far from exhaustive. There are always novel, interesting use cases that are being explored every day. This is an example of how this one might go around engaging in a certain round of open-ended evaluations in any specific area to decide what the next line of attack might be and what specific model areas you attack and so on. It is common, for example, to try and build some sort of a taxonomy that pertains to the client's areas of interests. You want to mix task difficulties in various ways. You want to try some single-turn conversations. You want to try some multi-turn conversations. And ideally, you want to sort of do an efficient breadth-first search of the space of interest and first have a view regarding what the weaknesses are, because that's what helps prioritize where improvements might be made. Now, let me quickly show you what different data sets might actually look like for SFT and RLHF. And this is often something that I have found valuable to show, because on paper, this might be training data. Labeling whether something is a cat or dog also might be training data, but they end up being a very, very different game altogether. So, for example, one can one can improve different open source models or whatever specific companies' models are in the coding domain by creating various kind of SFT data sets like this. And there are, again, many different flavors to how one can create coding-related data sets. It can be a pure coding-related data set. It can be something in the context of a repo. There can be tasks relating to explaining code, various other sorts of things. And again, new novel methods are being discovered every day. Again, today, it's certainly more of an art than a science, but I would love to see more research on the subject regarding even more principled ways to do it. It's the same even when it comes to agents, function calling, tool use, these sorts of things. This is again a very, very critical thing. Like, all of us are very excited by what LLMs can do in future. Can they call different APIs? Can they book tickets on your behalf? Can they do online research? Can they do all sorts of various things? Can they write SQL queries? Can they be a programmatic data scientist? All sorts of things. For this, function and calling and tool use is quite critical. The model should know what is the specific point at which it should write a piece of code, execute it, fetch data. If something is wrong, go back and try something else, do all that stuff, and ultimately give you what you want. These are the sorts of data sets for a programmatic data scientist. So let's say your company CFO wanted to know what your revenues will be in Q1 2025. Today, a senior data scientist might do a whole bunch of analysis on your various metrics and everything, and the person may come back with some report regarding where things might land, what various business risks are, etc. Imagine you wanted to enhance your models and enable them to have that kind of data science agent capabilities. It is exactly data sets like this that can be quite valuable. And this, of course, requires a team of expert data scientists. Then you can do this for various other industry verticals and expert knowledge. Like, for example, this is an example related to chip design. So if one is interested in improving the models for under-resourced languages like VHDL or Verilog, we can help with that too, and we actively do that today with a whole bunch of chip companies. Yeah, needless to say, there is similar things. One may be interested in assistants that can help with better technology integration. Then like high school level mathematics or college level mathematics is again foundational to a lot of reasoning. So there is things one can do there that involve that do not involve code. There's a way to there are some trade-offs with creating these data sets in a manner that involves code as well, but that has some trade-offs in terms of both costs and value. One can do this for PhD level physics, chemistry, biology, and other kind of expert subjects as well. One can do this for factuality and safety as well, where you're trying to get them modeled. A typical approach here would be to have various prompts and responses in areas where there are sort of known hallucinations that are identified in the evaluation data sets, break it down into claims, then create human data regarding the claims. There are some cases also where one directly tries to see if these are grounded in the different RAG sources and which specific RAG sources they are grounded in, and various sorts of labeling around that to help the model efficiently reason and ground things in facts. Yeah, this is an example of RAG labeling itself, which I was sort of forward referencing in the previous slide. Then today, a giant hole in all these models is their capabilities when it comes to image and text reasoning. So today, I would say even GPT-4o's model or any of the other state-of-the-art models, if you give it questions that involve fairly simple business graphs and a bunch of other text, like which might be important if you wanted to read a company's annual report and summarize it, or something along those lines. Its reasoning capability is not much better than what models were, say, 1.5 or 2 years ago, basically. So this is a giant hole, and there's a lot of companies that are certainly looking to fix this by means of such kind of data sets. There are other kinds of multimodality as well, where the previous speaker did mention various holes and challenges when it comes to reasoning around images and multimodal data sources, and we help with one can do that too. Then, of course, these are the standard these are a couple of example RLHF tasks. Now, of course, for any specific domain data analysis or all the different domains I showed you, one can construct various RLHF tasks. Now, how to construct the RLHF tasks itself is again, at the current moment, so much a matter of practice, and I'm not seeing too much research on that. Like an enormous amount of research I'm still seeing is so much on pure optimizations around preference data. But the reality is almost none of the state-of-the-art foundation model companies today do RLHF in that manner. All of them collect various other kinds of structured data. They collect process supervision data, and this ends up being an active area of empirical experimentation as well regarding what is the best way to collect this. Yeah, this is another example again. So based on our insights and our vantage point, doing all this, serving all the who's who of foundation model companies and everything, we have some thoughts regarding what might be some interesting research areas that we feel are profoundly important, but probably very, very under invested in today. So first is, I would say, the structure of human versus LLM intelligence. So I'd like to point out that I'm willing to bet very few people in this room know about the state of the art in intelligence research, starting all the way from Francis Galton, that was Charles Darwin's cousin over 100 years ago. And this is an active area of research. It's produced a lot of interesting insights, both bottoms up from the data as well as from insights from neuroscience and our understanding of how the brain works and everything. The figure on the right is our best understanding right now regarding how various human cognitive capabilities coalesce. Like particularly, one of the most profound findings there is the concept of the G factor, or general intelligence, and the fact that such a thing exists at all and has enormous predictive power. So I think some interesting areas could be things like, is there an analogous concept with LLMs? Can one actually measure a G factor of an LLM A versus a LLM B? How does one even measure it? Because a lot of the IQ tests that attempt to measure human G factor with the least bias and with the least variance will often fail with LLMs because of their knowledge of so many facts on the internet. And then, of course, the question is, does this lead to any insights regarding how this will, how to structure LLM post-training? Like today, I do hear about various sort of, again, empirical findings regarding first trying to train the model on some general capabilities and then trying to build up to some specialized capabilities, etc. But could the nature of human intelligence inform this in a way, and our research there? I think it's an interesting thing that is worth exploring. A second thing also is that it has been repeatedly found that there are enormous correlations between various specialized skills in humans and Now, we kind of sort of know that something like this happens with LLM training too, that when you improve the models on coding, it does improve reasoning and other things. It would be interesting to see if this ends up being quite analogous to the structure of knowledge and intelligence in humans, and whether there are any strong parallels there. Another thing is, I would say, is this LLM-driven vetting of human knowledge workers itself. So one of the key problems in making good quality human data happen is being able to vet a large pool of candidates, figure out who's most suitable for the job and everything. And in general, the goal of a test or an interview in this specific context is to run an operation that maximizes incremental information gain per unit time of testing. You want every minute to count. If two signals are highly correlated with one another, you probably don't want to waste too much time testing the second area if you kind of know something from the first one already. And needless to say, one also needs to weight such testing toward what sorts of tasks would actually be valuable from the standpoint of LLM improvement. Like an individual knowledge worker could have 5 different skills, but let's say only 2 of the skills really matter as far as improving LLM goes. Probably one wants to focus on that. Now, traditionally, there has been some research on testing. There has been some research on adaptive testing using LLMs. But first of all, that research has been quite narrow in terms of measuring one specific dimension, not a lot more. And the point is, expert human interviewers in various areas have often been able to adapt the interview dynamically. When they find they have enough signal in an area, they would instinctively not ask more questions or converse about that exact area. They would move on to something that is quite orthogonal to try and get maximum information gain out of the interview. LLMs could do a lot of this quite well. And also another exciting thing with LLMs is their ability to sort of to potentially evaluate how a person's thought process, the kind which again makes for efficient signal collection, which has historically been difficult in prior forms of testing. Then another bucket of interesting research, I think, could be just this, given a specific human team, how do you create tasks, workflows, review feedback processes, and everything that that generates steepest model improvements in the specific areas of interest. So, of course, there has been research on process supervision and everything, which have shown that individually designing tasks a certain way can be more valuable than say, than other ways, like outcome supervision. But the fact is that process supervision also takes more time to label, and the one really wants to engage in some kind of a joint optimization function, where you're saying that, all right, you have a specific team of knowledge workers at your disposal. How do you make sure you make every minute of their time count? How do you make sure you define the kinds of tasks that are easy for humans to produce at high quality, which would regardless be valuable to LLMs, basically, and not be so needlessly confusing for humans that even producing good quality data is difficult. Yeah, then I already mentioned this one, the fact that yes, there is so many variations of RLHF itself that are being empirically done. I'm not seeing enough of that in the research, and it would be great to see more regarding all those variations. And yeah, very closely related to some of this is also whether there are novel principled ways to use LLM as a judge, reviewer, co-pilot, and so on to work in tandem with an LLM human data trainer and produce high quality data. Even I mean, get to a better place when it comes to both quality and throughput. All right, thank you. I would like to mostly leave the time for questions.